Now let's try and attempt one more situation under line integrals. That is, we are going to attempt the evaluation of work done by a force field along two paths. One path is given by y is equal to 4, another path x equal to 6. Both are straight line paths and incepting from this point to this point. Before we incept this, it is advised that you always represent the situation graphically. And if I have to add one more thing incidentally, is that if you are in a conservative field, for example, it could be an electrostatic field, it could be a gravitational field, where the work done simply depends on the potential difference between the 2 points. That means it is independent of the path. But here we are saying that we are trying to compute the work done by considering paths. If the path is going to be different, then the work done is also going to be different. But that is not the case in case of conservative fields, where the work done is independent of the path. For example, if I lift a stone from this point to this point, whether I move along this point, whether I move along a curve, whether I move along straight, it doesn't matter. The work done is same, because it is the difference in the potential energy of the stone from this point to this point. And that is what we mean by conservative field. Now let's try and represent this situation graphically and then evaluate it. So that is the best way forward, because I am representing the path that I am taking. So first, along y is equal to 4, incepting from this particular point, which is characterized by 1, 4, the x coordinate is 1, y coordinate is 4. When I say y is equal to 4, the line is parallel to x-axis, and then it is at a distance 4 units from the x-axis. That means the y coordinate is 4, and it is at a distance 1 from the y-axis, and from the x-axis it is at a distance 4 units. So therefore this is what I am going to get. And then you are going to integrate it such that x is going to be kept constant. That is, x is going to be kept constant. You are hitting this particular point where the x coordinate is 6, the y coordinate is 4, so that you have traveled along this particular path, and here you are going to further travel along this particular point so that you get to this particular point. Is that clear? From 1, 4, you are traveling all the way to 6, 4. That is keeping your y coordinate constant. That means this line is absolutely parallel to x-axis. And then once you hit the point 6, 4, your x is kept constant, because you are drawing a line parallel to y-axis. That means your x distance, that is 6, is absolutely constant, but the y is varying from 4 to 6. So this is the path that you travel in order to compute the work done. First you compute the work done along this and compute the work done along the vertical path. If I have to name them, so it would be A, B, C. Am I right? I am naming them as A, B and C. So I will be getting work done along the two paths. One is AB and another is BC. So these are the two components of work done. One along AB, where y is kept constant, and another is along BC, where x is kept constant. So what is the expression for the line integral? If C is the curve or the path over which you are integrating, then it is f dotted with dxi plus dyj, right? X dotted with dxi dyj. Now I will be getting the two components as usual. So the first component is 2x plus y. So I'm going to get what? I'm going to get dx plus x minus 2yj. If I take the dot with dyj, then what I would get? I would get x minus 2y dy. Right? I'll get these two integrals. Now, first let me consider the work done WAB, that is, I am moving along AB. So, if I move along AB, what is constant? Y coordinate does not change, because you see, when I say a line parallel to x-axis, its y component or y coordinate remains constant throughout, and therefore can I write y is equal to constant? As a consequence, what happens if I differentiate? I get dy is equal to 0. That means along the path AB, my dy does not exist. So this straight away goes to 0. But what is the next challenge? Here I am integrating with respect to x, but there is a y coordinate. But I know that y is equal to constant, and that is equal to 4. So therefore, I can replace here y by 4 and then carry out the integration. As simple as that. Let me explain once again. First, the definition of line integral is f dotted with dr. Dr definition is dxi plus dyj, because remember we are in a Cartesian space. And what is the definition of this vector f? It is given by 2x plus yi plus x minus 2yj. And since I am taking dot product with the dxi plus dyj, I get these two components. The ith component, they get multiplied 2x plus y into dx. The jth components multiply themselves, x minus 2y dy. I get two components. Out of these two integrals, which integral survives? That is one with dx, because you can see along the path AB, x is varying continuously, whereas y is constant. That's equal to 4. So dy is equal to 4, y is equal to 4, and only this integral is going to survive for me to find the work done along AB, right? So this is the expression that I have to deal with. That is just to get the work done along the first path, that is AB. Is that clear? So therefore, what happens? I would be able to compute WAB. That's very simple. So that is along this particular component 2x plus y, but y now I am going to replace by 4. The reason being y is equal to constant along AB, so I am going to replace y by 4. And then of course dx. And how exactly my x varies? X varies, you can see, it was 1 to begin with, now it has become 6, because after that x is kept constant, y varies. So therefore my integration limits are going to be 1 to 6, because x varies from 1 and it all the way goes up to 6. So the integral is set up, limits are 1 to 6. The component of force that I need to integrate is 2x plus y. Since y is constant, dy integral component does not exist. Y is 4, and this is very, very trivial for me to evaluate. And if I integrate this, I will get 2x square by 2 plus 4x, and this is between 1 and 6. And this 2 would get cancelled. If I substitute the upper limit, it is 36. Plus if I substitute the upper limit for 4x, it is 24. Minus if I substitute the lower limit is 1 and minus 4. So this is 60 minus 5. So this becomes 55 joules. If I had to attribute a unit, I would attribute the unit of joules, assuming the force is in Newton and the displacement is in meters. So let me reiterate what exactly I did. So first, when I am asked to find out the work done using this force field, and my paths are y is equal to 4 and x equal to 6, I have sketched both the paths. How do you sketch? The moment you say y is equal to 4, it is the line parallel to x-axis with the y coordinate constant 4 being throughout, so I could do that. The moment you say x equal to constant, x equal to 6, it is a line parallel to y-axis, where the x coordinate is x equal to 6 is kept constant throughout, but you are incepting from 1 comma 4, moving first along x and then along y, and finally hit 6 comma 6, because you are incepting from here and hitting this. So if I have to calculate the work done for the given field, it is along two paths, AB and BC, and the standard definition of the line integral is this. We have introduced this comprehensively. We are in Cartesian space, so my dr becomes dxi plus dyj, and I have to dot that with respect to the given force field. When I dot that, I obviously get two components, ith component separately and jth component separately. Ith component, jth component. Why does the jth component does not survive? Because my integration is along AB. See, when I have this suffix C, that means I am carrying out the line integral across certain path, and that path happens to be AB. And along AB, you please note that the y does not vary. That means y is constant. That means dy is 0. And as a consequence, the second part, that is the jth component of the integral, goes, and only the ith component gets retained. And here also, you have got y, because y remains constant and the value of y is 4. I can always replace y by 4 so that I can integrate with respect to x. Otherwise, you are integrating with respect to x and you have y, it is not possible to integrate, right? So we will have to understand that also from the geometry. And what about the limits? Because you see, you move along y is equal to 4 from x equal to 1 to x equal to 6. After that, you move along x-axis, that is parallel to y-axis. After that, first you move parallel to x-axis, then you move parallel to y-axis, because your x becomes fixed, that is x equal to 6, and therefore you are moving from x equal to 1 to x equal to 6, then you move parallel to y-axis, and you will hit 6, 6. So therefore your limits are from 1 to 6. And the integration process is very trivial. When you integrate 2x, you get x square by 2 into 2. 2 would get cancelled. 4, when you integrate, you will get 4x. Upper limit, if I substitute, because it is just x square, it is 36. Upper limit for 4x, it is 24. Lower limit, it is just x square minus 1. It is just 4, so minus 4. 36 plus 24 is 60, minus 5 is 55, and I have attributed the unit of joules. So your WAB is comprehensively established. All that I got to do is find the work done along the other path and then add it up, right? That's all I got to do. Let's move on and do that. Now, for the other path, that is, let me re-represent instead of going back. So I started along this particular path. I called it AB. We computed the work. Now I am moving along BC, where your x coordinate is kept constant throughout, x equal to 6, and it is constant from B to C. So your x is constant, that's equal to C. So as a consequence, what happens? You very well know that the variation in x, or dx, is 0 because x is constant. And you are moving from one coordinate to another, that from B to C. What are the coordinates? You have moved from 1, 4 to 1, 4, 6, 4. 6, 4. Because you moved from 1, 4 to 6, 4. That means your x has varied from 1 to 6, which were of course our integration limits. Now from 4, you are moving all the way to 6, 6. 6, 4 to you are moving all the way to 6, 6. That means what are your limits? You are incepting with y is equal to 4, and then you are reaching all the way y is equal to 6. So which component survives here? Because if you consider the line integral definition, since you have ith component and jth component, you are going to have two integrals, 2x plus y dx plus x minus 2y dy. All right. So since we know that along path BC, x is constant, dx goes to 0, this integral goes home. So what we have for WBC, all right, is given by, WBC is given by the integral of this component of the force along BC. The limits are of course from y is equal to 4 to y is equal to 6, and x minus, since you are integrating with respect to y, everything should be in terms of y, right? That's a basic rule. Otherwise, you cannot integrate. So how would you replace x? Because we know that x is 6. Because along the travel, when you are traveling along BC, you find that your x coordinate does not change at all. It remains 6. So therefore, this integral finally becomes 6 minus 2y, and you are integrating with respect to y, and then 4 to 6. And this is what would give you the work done, right? So therefore, what exactly you will get? So the work done along the path BC, that is, I'm talking about parallel to y-axis. First we did parallel to x-axis, and your limits are from 4 to 6, because first y was constant, so it remained 4. Now it got augmented to 6. So it is 6 minus 2y. Y I got x replaced by 6, because when you are moving along BC, your x coordinate remains 6 throughout. So therefore, this is dy. And if I integrate, I will get 6y minus 2y square by 2. And your limits are 4 to 6. Of course, it is 2 would get cancelled. So if you substitute the upper limit, it is 36 minus 36. So that actually goes to 0. And if you substitute the lower limit, it is minus 24, because if you substitute 4 into 6, that is 24. And what about y square? That's going to be minus of minus, that's going to be plus, that's going to be 16, right? So if you integrate, you get 6y minus y square, because this 2 would get cancelled. If you put the upper limit, it is 36 minus 36, which obviously goes to 0. And then if you substitute the lower limit, you will be subtracting that from the upper limit. So it is 24. So minus 24. Since minus comes and you are subtracting, minus of minus becomes plus. So when you put y equal to 4, it becomes plus 16. So this would get cancelled, and you are going to get minus 8 joules. All right. So what did you get for AB? For AB, you had got 55 joules. Now for BC, I have got minus 8 joules. So what is the total work done? And remember, work done is a scalar quantity, right? So this is AB plus WBC. So that is 55 minus 8. So how much you are going to get? 47 joules. 47 joules. Attributing the unit of joules, assuming force in Newton and displacement in meters. So let me walk you through this very, very simple exercise, what exactly we did to begin with. Whenever you are given a line integral, that is especially when you are asked to compute the work done along a path, then please be sure of two things. One is graphical representation, and then the journey direction. That is very, very important. Direction of the path, whether you are going from here to here or here to here, because that can alter the limits of integration, and therefore you can get a totally different results. But here we are traveling from A to B towards the right, because you see the coordinate is increasing, and also it is given that first along y is equal to 4, then along x is equal to 6. So the path as well as the direction are both important, because you are talking about the vector quantities being evaluated, right? So the dot product being integrated, so both are important. So now I am incepting from 1, 4. I am keeping my y constant, y is equal to 4, and traveling all the way to AB. And in such a situation, what happens? Your y coordinate does not vary, and therefore dy becomes 0. So your jth component of the integral does not survive, because when you are given a force function and when you want to integrate, when you want to find the work done, you consider a vector dr, an elemental vector dr, which means what is the work done? That is when the displacement is dx along x and dy along j. This is the elemental work done that we are evaluating. Of course, we have given a detailed introduction for this line integral. And what exactly it means? F has got 2 components, y and j. It can also have 3 components, y, j, k, it doesn't matter. But when it has got 2 components, this elemental displacement is represented like this: dxi, dyj, that is elemental displacement along x, along y. Therefore, when you take dot product, you get ith component, jth component. But unfortunately, along AB, since y is constant, your dy is 0. So therefore, what happens? You get one integral directly going to 0. You have only one integral left. And along that path, since y is equal to 4, what we do? We replace y by 4, because there is a y here. that we are replacing by 4, and then integrating between the limits 1 to 6, because if you're traveling first along y is equal to 4 and going all the way from 1 4 to 6 6, that is x equal to 6 is your next travel path, then obviously you will have to hit a point where x becomes 6, because after that you're traveling along x equal to 6, there is no chance that you would be able to change your x coordinate. So you have to go to a point where x is 6. So therefore, in fact, you incept from 1 comma 4 and go all the way to 6 comma 4, because your y does not change and later on your y changes. So therefore, when you integrate, you will get 2x square by 2 plus 4x, upper limit and lower limit. Upper limit, when you substitute, see here it is 36, 4 into 6 24, minus, both of them are going to be minus because both are plus here. So x1 minus, and then x4, that is also x1 1 into 4, that is also minus. So therefore what happens, it is 60 minus 5, it is 55, as simple as that. And then what you have here is the second path, that is from B to C. Now we have already traveled from A to B, now we are going to travel from B to C. And along B to C, what is constant? X is constant, so dx goes to 0, so the first component of the integral goes to 0. And what about the second component? Second component does have a component x, which you cannot have because you are integrating with respect to y, but that x is known to us, that is 6 throughout the journey. So therefore I'm going to replace x by 6 and then carry out the mundane integration. So what would I get? I would get, if I integrate 6, I'll get y. If I integrate minus 2y, I'll get minus 2y square by 2. It is as good as y square. If I substitute, the upper limit is 36 minus 36, that goes to 0. Lower limit minus 6 into 4 is 24, and 4, if I substitute for y square, it becomes 16. Since there is a minus sign and you are subtracting the value of the lower limit, minus of minus becomes plus, that is plus 16. But 36 goes to 0. Minus 24 plus 16, that means minus 8 joules. But earlier you had what was that? 55 joules. So minus 8 plus 55, that is 47 joules. So therefore you have got the total work done along 2 straight line paths. So what is very, very important for you to take home in this discussion is that one is, of course, the graphical representation of the path is very, very important, and you must reckon your limits very, very carefully. And the third thing is whenever you are traveling on certain path, you must note whether the other constant, that is we are in Cartesian space, so if you are traveling along an axis parallel to x-axis, whether y is constant or varying, you should understand that. Only if you are traveling at an angle to x and y, then both vary. Otherwise, if you are traveling parallel to either of the axes, then one of the variables happens to be constant. If you are traveling parallel to x-axis, your y is constant. If you are traveling parallel to y-axis, your x is constant. That should be borne in mind very, very categorically. And the last incidental point I would like to remind you of is that in case of a conservative field, the work done is path independent, but in case of a non-conservative force field, the work done is indeed path dependent. So with that, let's move on and look at more discussions. Well, engineering and math are absolutely inseparable. We interventions day in and day out try our level best to make math as simple as possible and also of great practical value to every aspiring engineer. Do you want us to reach the masses? Please like us, share and subscribe. Do not forget to turn on the bell icon.